All right, before we begin today, you have to have a few things. One thing is your summary sheet. Yours is yellow, mine's white, with a unit circle. We had the back filled out on Monday. Second thing you'll need is your notes from Monday as well, where we were graphing angles. Okay, so our goal today is actually going to be to find the coordinates of all of these reference angles that we wrote down yesterday, or Monday. In order to do that, we need our special right triangles. So, we ended Monday with special right triangles. The first one we looked at was the 30, 60, 90 triangle with a hypotenuse of 1. Thinking back to your geometry, we know to set up a proportion for 30, 60, 90, across from your 30 degrees is the side length of 1, which is the shortest. Your hypotenuse is 2, and then the side across from the 60 degrees is square root 3. So if I'm trying to solve for this length, I can set up a proportion, which is what we ended with on Monday. So x over 1, so setting up that proportion, is the same thing as the square root of 3 over 2. So when we have a hypotenuse of 1, the second longest side is actually the square root of 3 over 2. Then I also want to find this other missing side, which is across from the 30 degrees. So this side on this similar triangle. I'm going to call it y. Setting up that proportion again, y over 1 has to be the same thing as 1 over 2. Well, anything divided by 1 is just itself. So when we have that hypotenuse of 1, the short side of our triangle is 1/2. Okay. We also talked about a 45, 45, 90 degree triangle, which is an isosceles, so I know once I find one side, I have the other as well. Again, we're still keeping that hypotenuse of 1. For the 45, 45, 90 triangle, our side lengths were 1, 1, and then the square root of 2. So again, I'm using that same process we just used for a 30, 60, 90 at the end of Monday with a 45, 45, 90. So x over 1 is the same thing as 1 over square root 2, or radical 2, either way is the correct way to say it. So I know that my side lengths are 1 over radical 2, 1 over radical 2. So why do we care so much? Why did you make the hypotenuse 1, Miss Ross? Well, that's where our unit circle comes in. So grab your unit circle. If you didn't label your degrees, go ahead and label them now. It goes back to our reference angles, which we talked about on Monday. Here is 30 degrees. Here is 0. 45 degrees. 60 degrees. And then 90 degrees. Then if I make that straight line, it's 180 degrees. And I think back to my reference angles. So if I look at this tick mark right here, it's going to have a reference angle of 30, 45, or 60 degrees. We use those because of the special relationship that they had for special right triangles. So if I go backwards 60 degrees from 180, I'm at 120. If I go backwards 45 degrees from 180, I'll be at 135 degrees. And then finally 30 degrees, if I go back, is 150. Same thing to label my quadrant 3, but instead I'm adding instead of subtracting. So add 30, and I get 210 degrees. Add 45, and I get 225 degrees. Add 60, and I get 240 degrees. This one was adding another 90 degrees, so that's 270. Then if I went all the way in a full circle, I'd be at 360 degrees. Again, using that reference angle. So here I'm going back 30 degrees. Here I'm going back 45 degrees. And here I'm going back 60 degrees. Okay, so you don't actually have to draw this, but I want to show you where those special right triangles are coming in. I'm actually trying to find this point. If I look, we see our x and our y axis. So this point is actually 0, 0. And the reason we had a hypotenuse of 1 is with a unit circle, our radius is always 1. So if I look first at, I'm going to use a different color, this point. Since this is my radius, I know I went over 1. And I didn't go up or down at all, so it's just 1, 0 would be that coordinate point. Please do write that down. Anything I write down in blue, write down. Then, when I go to find this point, we're actually creating a 30, 60, 90 triangle. Our reference angle of 30 degrees is 30 degrees because it's 30 degrees away from 0. And then all I'm doing is using those special right triangles, that relationship. So for my 30, 60, 90, if I look across from the 30, 60, 90, or across from the 30 degrees is that 1/2. So I'm using that same thing here. Across from my 30 degrees is 1/2. Then if I look, the adjacent side to 30 degrees is square root of 3 over 2. So square root of 3 over 2. So how does that help us find our coordinates? Well, if I look, my coordinate for my x is how much did I go over? Well, if I look at that triangle, I went over square root of 3 over 2. Then my y coordinate is just going to be how much did I go up? In this case, I went up 1/2. Okay, we can continue that same thing with a 45, 45, 90. So again, still making that triangle. 90 degrees, 45, 45, because that's the reference angle. Going back to my special relationship with a hypotenuse of 1, both sides are going to be 1 over radical 2. So the adjacent side and the opposite side. So if I look at that point right here, I went over 1 square root 2, and I went up 1 square root 2. So x is your horizontal change, y is your vertical. Okay. And then last but not least, that 60 degrees reference angle. Going back to my special relationship. So before we were looking at 30 degrees, now I'm going to shift to my 60 degrees because that's my reference angle. So if I look at my adjacent side, it's 1/2. And my opposite side is going to be square root of 3 over 2. So when I look at that coordinate, how far over did I go? 1/2. How far up did I go? Well, that's that length of that triangle, which is the square root of 3 over 2. So I just found those 4 points. The last one is 90 degrees. 90 degrees doesn't have a reference angle, so I have to use the fact that my radius was 1. I didn't go left or right any, so that's going to be 0 for my x value, but I did go up my entire radius, which was 1. You'll notice on every single homework assignment, we're always going to have you label these coordinates because we use them for the rest of this unit and next unit. So knowing these are going to be very beneficial, which is really just going back to your geometry and your special right triangles. The only thing we're restricting is your radius is 1. Now, how come I don't have to keep drawing triangles for the rest of them? Well, It all goes back to your reference angles. If I look at 120 degrees, the first thing I notice is here's my x-axis and my y-axis. If I'm on the left-hand side of my coordinates plane, all of my x's are going to be negative. Here they're positive, here they're negative. If I look at my y values, because I'm still in my second quadrant, all my y values are positive. So once I get those signs noted, all I have to look at is my reference angle. So for 120 degrees, remember for reference angles, we always compare back to the x-axis. So from 120 degrees to 180 is 60 degrees. That's my reference angle. So my coordinates are actually going to be the same. The only difference is that negative x. If you think of transformations, you can think of all we did was take this point and reflected it over the y-axis. To do that, all you had to do is change your x. 135, your reference angle is 45 degrees. So I'm going to look back at my first quadrant, 45 degrees. It was reflected, so that's why that x is negative. Or you can think in this quadrant, x's are negative. 150 has a reference angle of 30 degrees. So it's going to be the same coordinates. Only difference is my x is negative. Okay. If I look at 10, same thing. I'm going to reflect it over and change my sign of my x value. Now I'm going to look at my third quadrant. What I like to do first is write down my sign so that I know is it going to be positive or negative. In my third quadrant, both my x and my y are negative. Those are negative signs, that's a comma. And then, still going back to my reference angles. Knowing your reference angles are crucial. So 210 degrees is 30 degrees away from 180. So when I look at my coordinates, I'm going back to 30 degrees. Square root of 3 over 2, 1/2. Always go back to your reference angle. 225 degrees has a reference angle of 45 because it's 45 degrees away from 180. Then 240 has a reference angle of 60 degrees, so it's going to be the same coordinates. Finally, for 270, you can actually think of it as a reflection of 0, 1, which is going to be 0, -1. Or think about here's your origin, 0, 0, and all I did was go down 1. I actually want you to try to pause the video and try the last 3 without my help and come back when you're ready. All right, so I'm going to start with 300, which has a reference angle of 60 degrees. Before I do that, I want to think about what's negative in this quadrant. My x's are all going to be positive, but because I'm in my fourth quadrant, my y's are negative. So this has a reference angle of 60 degrees. Probably didn't leave myself enough room, but that's okay. So my x's stay the same, but now my y is negative, which think of this as a reflection over your x-axis because that's all we really did. 315 degrees has a reference angle of 45 because it's 45 degrees away from 360. So I'm going to use 45 degrees. And then 330 degrees has a reference angle of 30 degrees. And we just labeled our coordinates. Really? People ask me, do we have to memorize this, Ms. Ross? No, please don't try to memorize all of this. If we have the first quadrant, we can find everything else because it's all going back to your reference angles. I also wouldn't really encourage you to memorize these because there's lots of 2s, 3s, and 1s, and it gets confusing. So think about your special right triangle, like I did going over that first quadrant. Okay, I want you to keep this to your side.